Good morning, everyone. Welcome to lecture 13 of problem solving and computer programming course. So, in today's lecture, we are going to see about couple of topics that are related to function, right? So, first we are going to discuss what is called as top-down design. I'll also tell you about the bottom-up design here, so that you can differentiate what is the difference between top-down design and bottom-up design. Second, I'll tell you about some of the predefined function. Some predefined function you have already used in your lab class, like you have used sqrt function. You have also used pow function, right? So these functions are called our predefined functions. We are going to discuss about these functions and their associated header files, right? So if you want to use a particular function, right? So you have to include their respective header file, right? That you have to know, right? Which header file is applicable for which function, right? Then we are going to see programmer defined functions. Means you can develop your own function, okay, and you can use that function in your program. That is called as our programmer defined function. Will tell you, right? In which I am specially focusing on two parts. One is function definition, right? One is function definition, another is function declaration, right? Function definition and function declaration. These two parts you have to know, right? And you will see which one is optional and which one is compulsory, right? And when it is optional, that we are going to discuss. Then I'll tell you about the procedural abstraction, which is very much essential because you are learning C++, which is object-oriented programming. So one of the features of C++ is abstraction. Next, we are going to see local variables and global variables. I'll tell you how to declare a global variable and what is the scope of the global variable and local variable, right? And at last, we are going to see overloading the function. Overloading the function means the same function with different parameters, right? Suppose you want to call a add function, right? But with different parameters. One case you can say add function with parameter 2 integer, add function with 2 parameter as floating point number, add with three parameter. Three are out of three, two are integer and one is floating point number or double number, right? So same function name you are using, okay, with different parameters or arguments. I'll tell you about parameters, parameter and arguments, right? If you want to know, right? So we'll see how the program taking based upon the input, how it is taking the correct function, that we are going to see. So it is one of the feature of one of the properties that we called as polymorphism. If you remember one class I told you about polymorphism. So polymorphisms one providing one feature that one function can be treated differently based upon its argument, that we are going to discuss at the end. So let us start with the top-down design. As the name suggests, top, as you can remember like this, top means it is the nothing but in top there is a big module is there, right? Suppose I will give you 100 assignments and I will tell you by tonight you have to complete the 100 assignments. Okay. So what will happen? It is not practically possible, right? So what you will do? You will group the assignment into, you will share the assignment among your batchmates, right? So what you can do? You are specially decomposing this assignment into multiple parts, right? Let it be in each part you have around 20 questions. This part having 20 questions, this part is having 15 questions, this part is having 15 questions, this part is 20, and this part is 20, and this part is 10. Okay. So you cannot, if you solve a single module, it is very difficult, right? So what you did, a single module is divided into sub modules, or you can say a single task is divided into subtasks, right? So decomposing in this manner is called as your top-down design. right? Initially you are assigned with a big work and you are dividing the work among multiple people. In company also, whenever you are whenever you go for building a particular software, so one person cannot build the software. What happens? We are dividing the software into multiple modules, and each module will be taken care by one group of people, right? One group of people will do the requirement, group of people will do the design, another group will do implementation, another is testing, another is maintenance, and so on. So they are processed like that. Okay, such designs are called as the top-down design. So in our case, if you see, our objective is to write a program, right? Whether it's C++ program or Python program, our objective is to write a program. So before writing a program, I told you, you have to develop the algorithm or pseudocode. Okay, so develop the algorithm, and this algorithm you have to write in such a manner that it's not a particular programming language like C++. Okay, so it should be free from programming language. Anybody can read this algorithm, right? Anybody can read this particular algorithm, whatever you have written. Based upon that, he can write the code in his own expertise language, right? So once you build the algorithm, the next step is you are translating the algorithm into a programming language. So whoever is there in the implementation team, they are comfortable in C++, so they will take your algorithm and implement in C++. Another development implementation team, they have expertise in Python, so they will write in the Python, right? And this top-down design also called as our stepwise refinement. Each and every step you are doing the refinement, right? So what it is saying, you have one algorithm, right? That algorithm, you have to break that algorithm into subtasks. Like you know that in each and every algorithm, it is a stepwise process, right? Step 1, step 2, step 3, step 4, you are writing. So each and every step is a task, right? Rather than writing everything into a single line, we are writing various steps or various lines we are writing. Similarly, each task, each algorithm is divided into subtasks. Similarly, a subtask can also be divided into subtasks. Okay, it is not that the subtask is the last one. Based upon the necessity, you can also decompose the subtask into some smaller subtasks. So what you are doing in each and every process, you are dividing your work into multiple chunks or multiple parts or multiple tasks. Okay, so that is done in the case of top-down design. So eventually, the smaller subtasks are trivial to implement in the programming language, right? So software consists of a set of program. So you can say each and every program belongs to a subtask, right? So this is called as our top-down design. So subtask or called a function in C++ make a program easier to understand. You can easily understand because suppose I want to write a program for calculator. In calculator, you know there is addition function, multiplication function, division function, and subtraction function, modulus function. A lot of functions are there. So calculator is our program, right? For that I need to write an algorithm. That algorithm need to divide it into subtasks. Okay, subtask is divided into smaller subtasks. So each and every smaller subtask may be one is for addition function, another is for multiplication function, another is for the division function, another is for the subtraction function. Okay, so each and every subtask I am representing in the form of function. What is the necessity? If there is some mistake in the addition function, then I can directly go and directly modify. So it is easier to change. But if you have written a single program without going for subtasks and functions, then what happens? It is very difficult. And one instruction may affect other instructions as well if there is a link between two different instructions. So it is easier to write and easy to test, easy to debug. If any error is there, you can easily identify and correct it, right? And easier for the teams to develop. So that is the benefit you are going to get in the top-down design. But what happened in the bottom up design? Bottom up design, you are doing the reverse process. Reverse process means already some small tasks are there. Like each and every class I am giving you assignment. So each and every assignment can be treated as subtask. And at the end or in some bit in between, I will tell you, you have to submit the assignment. So what you have to do? You have to group all the subtasks to a single task, right? So you have a lot of subtasks. You have solved each and every subtask in each and every class, right? After each class, so you have the answer. Only you are consolidating everything and giving your report. Okay, so that is called as your bottom up design. So based upon the necessity, we are going for top down design or bottom up design, right? But if here we are using top down design in the case of C++. Now come to the predefined functions. Before going to the function, let us know what is the difference between predefined function and programmer defined function. Predefined functions is already there in the system, you can use it. Like sqrt you are using, pow function you are using. But programmer defined function, you need to specify. If you are writing add is a function, you have to define what is there inside the add. Okay, like you are putting a plus sign, it indicates that two operand is there, plus is an operator, they are adding each other and output is produced, right? So that is a defined. Plus for plus it is already code is there, right? System code is there. But whenever you go for add function is not there in C++. So you have to specify what should be there inside the add. That is called a programmer defined function. So let us proceed for first one, that is predefined function. So C++ comes with libraries of predefined function. There are many predefined functions are there. Okay. One of the very best example I already gave you, that is called the sqrt function. Okay. And sqrt function is taking only one argument. You can see this is called your argument or parameter, right? So whenever you are writing sqrt within bracket a argument, so it will return the square root of a number, or it is calculating the square root of a number, and whatever result is coming, that is square root of 9, that will be stored in the variable the underscore root. Okay, so the underscore root contain 3.0. Okay, because it is a double number. If you have defined double the underscore root, okay, you have specified the variable type of the underscore root is double, right? So the root will contain your value 3.0, which is nothing but square root of a number. Similarly, you can write, if you are interested to write a programmer defined function for the square root, then you have to write the code for square root, how you are going to calculate the square root of a number. But it may be more complex. If you go for today's language like Python, there are a lot of libraries are there. So no need to write the code for these small things. Okay, but if you write, that will give you more programming flexibility. Okay, or you learn the how to write the base code or fundamental code. But nowadays people are simply using the function and they are writing the code, which is not good. That is good if you are building a big program for which you can use 5-6 functions. But if there is a question square root of a number, then you should know that how to find the square root of a particular number and how to write a code for it without using the predefined functions. So sometimes in the exam or in the question papers also, the question is like that, do not use the predefined function. So you cannot use any predefined functions. You have to write your own function. Okay, although predefined functions are there, but you have to go for programmer defined function. So square root sqrt 9 is a function call. Main is a function. So you know that a string, main is a string, right? That is nothing but a group of character followed by a parenthesis start, open parenthesis and close parenthesis is a function. Like you are writing main is also a function, right? Suppose I'll write add is my user defined function or programmer defined function. I want to write multiply mul is a function. Okay, so it is also a function call, but exact function call you will know whenever you go for programmer defined function. But really here the function calls happens, but we do not bother because our control is not going anywhere. Okay, because sqrt is already defined. But if sqrt is not defined, suppose you want to write sq is a function. Okay, this is your user defined function or programmer defined function. So in that case, what happened? You have to write the square root of number program, right? So in this case, the function, the compiler, whenever it will execute, the control moves from one position to another position. Okay, so sqrt9 it invokes or sets in action the square root function. Okay, and the argument is 9 can also be a variable or an expression. Sometimes I can tell you, suppose x is equal to 9.0. So what you can write here is sqrt within bracket you can write x. That is also fine. Similarly, you can also write an expression. There is no issue. Okay. A function call can be used like any expression. That is, expression is also okay. So here you can see I have written bonus is equal to sqrt of sales. So sales is a variable. It is not like your n, that is a constant. So but you have to assure that the cells you have defined prior to this particular statement. Otherwise that is meaningless. Right? So divided by 10. Similarly, you can see here I am asking the side of a square with area. Right? Side of a square with area. Then user will input one value, right? Let's say 10 or 20, something like that, which will be okay, which is already there prior to this one, that will be displayed here. Okay, and is the side of a square with area 10 is nothing but square root of area. The square root of area will be calculated, whatever value is coming, it will be displayed here. Okay, but make sure that area you have defined, declared and initialized prior to this cout statement. Right? Now, let us see this particular program. This program computes the size of a dog house that can be purchased with a given user budget. User will enter the budget and you know that what is the cost per square feet and you have to calculate what is the size of a dog house. Right? What we do here? We have declared a constant. In order to declare a constant, you have to use const keyword. Then it is of double type, data type is double, and I have declared cost underscore per underscore square underscore feet. Generally, constant is declared in the capital letter is equal to 10.5. Okay. Then I have used some other variable, that is budget, area, and length underscore side is your double type. Right. Then I am asking the user enter the amount budgeted for your dog house in dollar. So user will give input what is the budget. Whatever budget is user is giving input, that you have to store in this variable, that is budget. Right? Now you have to calculate the area. So area is nothing but budget divided by cost per square feet. So if a user is input 25, so 25 divided by 10.50. That is called as your area. And once you determine the area, you have to find the square root of area. Right? SQRT function within bracket area. So that will be stored in the length underscore side. Okay. So this is a predefined function. SQRT is a predefined function and it is defined under our hash include CMath. Okay, that's why you can see here, instead of using in addition to hash include IOStream, we have used hash include CMath. So SQRT is defined under CMath. So if you have not written CMath, you will get an error. Right? Then you know that you are writing cout setup iOS fixed, iOS show point, and cout precision 2 to show up to 2 decimal place. Okay. So here you can see we are giving input as 25, right? For a price of 25, then it is printing for a price of dollar. Budget is our 25 as user is specified. Budget is 25. Then there is a line break. Then it will show I can build you a luxurious square dog house. Then it will come to next line. That is the length underscore side. What is length underscore side? That is nothing but square root of area. That is nothing but square root of budget divided by cost underscore per underscore square underscore feet. So budget is how much? Budget is your 25 divided by your 10.50. Then it's square root. How much you are going to get? If you calculate it, you are going to get 1.54. So it is displaying 1.54 in place of length underscore side. Then it will print feet on each side. Okay. So the idea of this particular program is to show you how the predefined function is used. And note that if you are using any predefined function, its corresponding header file needs to be included. Otherwise, you will get an error. Right? Now, this is the syntax. You can see we are writing a function name. Right? Let us take our function name is main, also is a function, and argument list is empty in the case of main. But in the previous case, we are using sqrt is the function and argument list is nothing but area. So a function can take more than one argument as well. Like you can see here, I am writing the argument list is nothing but argument 1, argument 2, like that argument n. Multiple arguments are also possible. Right? So you can see an example here. Here we are taking only one argument, that is area. Square root of area we are storing inside. But in the second case, what we are doing? We are using a function that is pow, but it is taking two different arguments. If multiple argument is there, they need to separate by comma. So what it indicates? It indicates 2.5 to the power 3.0. So in the output, it will show 2.5 to the power of 3.0 is this message it will print, and the value that is power of 2.5 3.0 will be calculated and displayed as your output. Okay. Now, function libraries. Predefined functions are found in the library. Like you have seen, there is a CMath library. Right? The library must be included in a program to make the function available. If you are not including that library, you are going to get an error. Okay. So an include directive tells the compiler which library header file to include. Right. For example, in the case of sqrt, we are using CMath as the header file. Okay. And you have to use this using namespace std, because it is providing special names to a specific function. That's why newer standard libraries such as CMath also requires the directive like you are using namespace std, providing specific name, standard name to each and every function. Right? Similarly, other predefined function, another function is ABS. ABS stands for absolute of a particular value x, variable x, right? Like you are writing int value is equal to ABS of -8. If you input give your input is -8, so it will take as a +8. If you are writing +8, it is going to take +8 only. So ABS returns absolute value of argument x, and here you can see the return type of the value is int. Okay, and argument, there is a single argument. Absolute takes here a single argument, that is x, and the value of x here it is -8. So if you want to use the absolute function, then you can use the library cstdlib. This library you have to use if you are going to use the absolute function, right? Similarly, you can see if you want to go for absolute of a floating point number or a double number, what you have to write? double value, instead of writing ABS, it should be preceded by FABS of minus 8.0. Okay, so it will return you 8.0. The only difference with this ABS FABS is it is applicable for integer and it is applicable for double. And you can see here return type is int, here return type is your double. Okay, so the value is in the first case it is holding the integer type, but here it is holding the double type. And it is also found in the CMath file like SQRT. It is finding. You can, if you want to use FABS floating point absolute, okay, then you can use the CMath, right? LIB stands for your library here, right? CSTD library. So here you can see a couple of functions and with their header file, like you can see here, SQRT and POW is coming under our CMath header file. Okay, and SQRT takes one parameter, POW takes 2 parameter. Okay, as it is your output is a double number, so what you have to do, you have to take everything as a double data type, right? Because there is no integer. When you calculate the square root of a number, you may get square root of 3, right? So you may not get a complete integer. That's why better to declare is a double number. Similarly, ABS or long ABS, they are defined under your CSTD library. CSTD library, right? Similarly, if you want to use FABS, that is for the absolute value for double, or the ceiling function or the float function, you have to go for CMath header. Seal, if you are writing seal of 3.2 is your 4. You will be rounded to the next integer, right? Seal of 3.9 is also 4. Seal of 3. Seal of I'll write 3.001 is also your 4.0, right? But whenever you go for floor, right, floor 3.2 is 3. Floor 3.9 is also 3. Even if you write floor 3.9999 is also 3. Okay, it will go to the previous integer, but ceiling is going to be your next integer, right? So these mathematical functions are required whenever you are writing the code. So you can use these functions directly, right? But if you are interested, you can also write the code for it. How to do the coding for the ceiling function, floor function, FABS, ABS, LABS, SQRT and POW function, so that your programming skill can be enhanced, right? Now come to the typecasting. Typecasting is nothing but if you want to move from one type to another type, then we require typecasting, right? But whatever typecasting I am telling now, it is a old type. Nowadays we are not using that. I'll tell you what we are using today, but what is used in previously, that also you should know. You can see here there is a very good example that the total underscore candy is 9, number of underscore people is 4. So both variable, the number of people and total candy is declared as an integer type, right? And we have declared candy per person. 9 candies are there. We have to distribute it among 4 different people. So 9 divided by 4. Okay. So that's why I am writing double candy per person. I have to calculate. So candy per person is total underscore candy divided by number of underscore people. Where total candy is 9, number underscore people is 4. So 9 divided by 4. But 9 is an integer, 4 is an integer. So the division of 9 and 4 is also a integer. Okay. So your expected output is 2.25, but you are going to get 2. Because integer divided by integer is always an integer. Okay, so what you need? You need typecasting. So if you want to typecast here, what you have to write? Either total candy before total candy you can write static underscore cast. Within these less than and greater than you can write double. Okay, it will work. It will convert the integer to a double number and accordingly it will calculate. Or you can write the same thing, static underscore cast double. Okay, and within bracket you can specify number underscore of underscore people. Either you use this one typecasting prior to this one or prior to this one, both will work. Okay, so that integer can be converted into double. So here you can see the same program I have written. Total candy is 9, number of people is 4, candy per person is a double variable. So I am writing candy per person, I am writing total candy. Prior to total candy, I am writing static cast double. So total candy is your 9, right? When you write this one, it will be treated as 9.0 divided by number of people is 4. So you are going to get your output as expected, that is 2.25. Okay. Or what you can do, you can use static underscore cast double in the denominator part. Right, that is also fine. That is nothing but 9 divided by 4.0. So you are going to get your output as expected, that is 2.25. That is also possible. Okay, but you should not write like this. You are writing static underscore cast underscore double, but within bracket you are specifying total candy divided by number of people. Total candy is 9 divided by 4. So 9 divided by 4 is nothing but your 2. So first you know that if there is something is written in the bracket, that will be evaluated. So when you evaluate this particular expression, you are going to get 2. Okay, then 2 is converted to a double number. That is, there is no meaning. Either this integer need to be converted or this second integer need to be converted to the double. So integer division occurs before the typecast. So you will not get your output as 2.25. You are going to get 2. Okay. So whenever you are typecast, you have to be careful. Right. So this is a old style of typecast. C++ is a evolving language. This older method of typecasting may be discontinued in future version of C++. Now it is discontinued. What we are writing? We are directly writing the double. Like you can see here, instead of writing the long one, like you have seen here, static underscore cast within bracket, you are writing double. Okay, so here we are writing simply the double. Double total candy divided by number of people. Okay, or you can write total candy divided by double number of people. Both will work. Okay, both will work to typecast a integer to a double number. Right. So now this is the conclusion for this predefined function. So you determine the value of d. D is declared as a double number, and 11 to you know it is an integer. So what is the result? You determine the value of these functions like pow function with argument 2 and 3, fab function with argument minus 3.5, square root function, and inside the square root function you have another function, that is pow, having two parameters 3 and 2. What is the output? You find it. 7 divided by absolute minus 2, seal 5.8, floor 5.8. To determine what is the output. Similarly, you convert the following expressions or following mathematical equations into C++, because you know how to represent square root, how to represent the power, right? X to the power y plus 7. How you are representing, you know. Okay, so try to convert the mathematical expressions into your C++. So the next point of discussion is nothing but programmer defined functions. So whatever we discussed till now, that is predefined functions, right? Programmer defined function do not require any header file, right? But in the predefined functions, you have to specify the header file. Okay. So there are two components in this function, programmer defined function. First one is called as function declaration. Don't be confused, it is very important. One is called as function declaration, which is called as function prototype. Okay, like you are doing variable declaration, you are doing function declaration. and you are specifying the details about that particular function in the function definition. That's why there is two parts. One is function declaration, another is function definition. So if you are going for function declaration, it shows how the function is called. It is not specifying what is the internal details of the function. It simply says how the function is called. So it must appear in the code before the function. Whenever you are writing a particular function, prior to that, generally we are writing function declaration or function definition. So one of the example you can see here, type underscore return, function underscore name, and there is a parameter list, and it should be ended with a semicolon. Right? Type means you can write double. Function name you give add, and you specify you want to add to double number. That parameter list you can write here. Okay, and better to write a comment which describes what the function does. Whether the function is doing addition, multiplication, division, or it is calculating the income tax, okay, or it is calculating the total VAT applied to or GST applied to a particular product, something like that you have to specify. Second part is a function definition. The function definition describes how the function does its task. The details you have to specify in the definition. So it can appear before or after the function is called. Whenever you are calling a particular function, before that you can apply the function definition, or after that also you can specify. Right? And the syntax is you have to specify the type, instant, maybe double, function name, parameter list, and within a curly bracket you have to write the details about that particular function. Right? So first part is function declaration, second is function definition. Right? So come to function declaration, the first part tells the return type, tells the name of the function, how many arguments are needed, and also the types of argument. Types means whether it is an integer, a double type, or float type, or character type, that we have to specify. And tells the formal parameter. So there is two type of parameter we are using in the function. One is called as the actual parameter, another is called as the formal parameter. Okay, actual parameter we are providing to the formal parameter, and after the calculation it will be again written to your main block. So formal parameters are like our placeholders. Okay, for the actual arguments used when the function is called. Whenever you are calling the function, you are supplying the actual argument. Okay, but it is captured as a formal parameter in the function side. Formal parameter names can be any valid identifier. You know that identifier, how to declare an identifier. An identifier starts with the alphabet or underscore. Okay, you can write that, but there should not be any space. Right? So this is an example. You can see I have declared the type as double. Function name I have written total underscore cost, and it is taking two different variables. One is number underscore par, which is a integer type, price underscore par, which is a double type. So two different variables you have declared. That is your function declaration. Declaration always ends with a semicolon, and declaration is optional. Declaration is not compulsory. I'll tell you in which case it is optional, right? And we are writing a couple of command lines to specify what this function indicates. So we are writing computing total cost including 5% sales tax on, and number underscore per items at the cost of price underscore per each. Some command line you have to write so that one person can understand why you have written that. Come to function definition, that is the second part. Provide the same information as the declaration. Declaration you have mentioned double total underscore cost, int number underscore par, double underscore price par. But you are not putting semicolon in the case of function definition. Right? We are not specifying any semicolon here. Right? And inside the curly bracket, whatever statement you want to write, you can write. Like here I have specified tax rate is a double type, which is a constant of 0.05, which indicates the tax is 5%. Then double subtotal. Subtotal can be calculated as whatever the price is there, you multiply with the number of items, right? You have purchased, let's say, 10 number of chocolates, right? Your number is 10, price is, let's say, 5 rupees. So 5 into 10 is 50 rupees. And total is nothing but, if you calculate, subtotal is a 50 rupees, 50 plus 50 into tax rate of 0.05. Okay, 5% of your 50 rupees. That will be calculated. That will be returned to your program. So this is called as your function body. Okay, and the first part is called as your function header. Right? So always a function ends with a function call. Right? It returns the value calculated by the function. Like you can see in the last line, I have written return followed by some expression or a particular variable followed by semicolon. So this is the syntax. Return expression. Okay. So here expression is a variable containing the calculated value. In the previous slide, as you can see, I will return subtotal plus subtotal into text underscore array. Okay, in this way you can write a return function. And return is compulsory for a particular function. Like in the main function case, you are writing return 0. At least you have to write return 0 to formally exit that particular function. So whenever you call a particular function, you tell the name of the function to use. Which function you want to call that? You have to specify, and you have to specify the list of arguments. And these arguments are called as your actual argument. Okay. And it is used in a statement where the return value makes sense. Like you can see here, we have written double bill. Bill is a variable which is of double type. Total underscore cost is a function which takes two parameters. One is number, another is price. Two parameters handled by this particular function. Okay. Here, this number and price is called as your actual argument. Okay. Whenever this number and price will be supplied to a particular function, the function captures it as a formal argument. Right? So you can say it is a copy of your actual argument. So this is a program you can see. Here what we are doing, we are calculating the total cost including 5% sales tax. So I am asking, enter the number of the items purchased, enter the price per item. Then I am calling a function, it's called as your total underscore cost with two parameters. One is number, number you specify and price you specify. Okay, and you supply it to a function that is called total cost. Okay, so if you have defined, if you have given the function definition prior to this particular function, try to understand, if you have defined your function prior to its use, then function declaration is optional. So you can see in the very beginning, we have declared the function. What it indicates? This function exists in this particular program. But where is that function? The function is after the main function. But if this piece of code, if you have written here, then what will happen? This line is not required. This function declaration is not required. Okay. So you can see whenever you are writing total underscore cost number and price, number is given as input to number underscore pair. Price is given input to price underscore pair. So this is your actual argument and this is your formal argument. Okay. And you have already specified there is a function total underscore cost. Its type is double. It takes two input. One is number underscore pair and price underscore pair. Right. Sometimes you need not specify this also. Number underscore pair and price underscore pair. Simply you specify int comma double. What it indicates? First argument is integer type. Second argument is double type. So when you supply this value to this particular function definition, so you can do a calculation here. Like you have declared the text that is constant, that is 0.05, and it is subtotal. Okay, and subtotal is calculated, that is nothing but price into the number and the text rate of 0.05. So this is your function header, as I mentioned. This is your function body, and entire part is called as your function definition. But don't be confused. What is function declaration and function definition? Function declaration is same as our variable declaration, right? Definition is telling about the internal details about that particular function, right? So whenever you will give input 2 is the number of items and price per item is $10.10. So you know that it will multiply 2 items of $10.10. You are going to get 20.20. Okay, 20.20. And you know the text is 5%. So it is multiplying the text rate with 20.20. So which result the total of 21.21. Right? Okay. So now there is two things. We'll go in details in the later classes. One is called as your call by value. Another is called as your call by reference. The value of the argument are plugged into a formal parameter. Call by value mechanism with call by value parameters. I'll tell you what is the difference call by value, call by reference in the later classes. So what happens whenever you call these functions, the first argument is used as the first formal parameter. Second argument is your second formal parameter. Like that, if you have 5 parameter, it will be assigned accordingly. So the value plugged into the formal parameter is used in all instances of the formal parameter in the function body. Right? So here you can see, suppose I am providing number as 2, as I told you in the output, number I have specified as 2, price I am specifying as 10.10. So this number 2 is assigned to your number underscore pair. First argument is assigned to first formal parameter. Second value is assigned to second formal parameter, that is 10.10. Okay. So after that, what it is doing? It is calculating subtotal plus subtotal into tax rate. And subtotal is nothing but price per into number per. Price per means price is nothing but your 10.10. Okay, 10.10 multiplied by 2. So you are going to get 20.20. Okay, that is your subtotal value. You have to multiply with your tax rate of 0.05. And this will be returned, and the entire expression is replaced with this return value. Okay, here we are getting the value as 21.21. So now the bill value is 21.21. Right? So here you can see you have specified up to 2 decimal place. So it is going to show up to 2 decimal place. And for the before decimal point, you are writing this code. For after decimal point, you are writing this code. That is iOS scope resolution operator fixed, iOS scope resolution operator so called. So in this is called, right? Alternate declaration. There is 2 forms of function declaration. You can specify the formal parameters names. You can also specify the types. I already mentioned this thing. That is double total cost. You can specify int number underscore pair, double price underscore pair, or you can simply mention int double without specifying these variables names. Both are okay. So function header must always list the formal parameter tools. But whenever you are specifying the function header, okay, you have to specify the formal parameters names like number underscore pair, price underscore pair, right? So compiler checks that the types of arguments are correct in correct sequence. Like you can see here what we did, we have 2 variable. One is received underscore pair, another is mean underscore score underscore pair. Okay, in the next expression you are writing received is 95 and minimum score is 60. So you can see here you are declared received underscore pair, but here you have mentioned received. Okay, it may happen because this is actual argument and this is a formal argument. If it is actual and formal argument, it is allowed. So the main point of discussing here, you can see received underscore pair is same as your received, and minimum underscore score underscore pair is same as your minimum underscore score. Both are same. Okay, and there is a specific order. This is a order, this is another order. But whenever you are displaying, you are specifying mean underscore score and receive. So they are not in the correct order. That's why you have to focus whenever you are passing a value or whenever you are printing a value, you have to specify that each and every variable's value, whatever you are written, that should be the correct one. So if you are calling the function grade, the first parameter always is nothing but received underscore pair. Second one is your mean underscore score. But if you have alternate this one, then your output is expected that you are going to get faulty result. And the compiler is not going to identify this thing. This is your mistake. You have to identify. So you can see here, for example, here you have declared you have the function that is character takes two parameters, that is received pair and minimum score pair. So execution starts from the main function. Here you are displaying a message that is enter your score and minimum need to pass. Suppose my score is 80 and minimum need to pass is, let's say, 50. Right? So you have given input 80 and 50. So 80 is taken as score, 50 is taken as okay. Then you are calling a function grade, need to pass is 80 and score is 50. Sorry, need to pass is your 50 and score is 80. So you have given alternative value. Instead of writing score and need to pass as an argument, by mistakenly you have written need to pass and 80. So you know that if your score is greater than your minimum mark, then you are pass. So P will be printed for the pass. P is representing passing. Okay. But you have supplied 50 and 80. So it is going to check 50 is greater than 80. Which is will return, it will result false. So you will be surprised whenever you will see the output. So if you are not representing this in the correct order, so whenever it will call the function, so it is capturing need to pass is nothing but received underscore pair. Score is nothing but minimum score pair. And it is checking received is greater than equal to minimum score or not. So first value you have supplied is 50. Second value you have supplied is 80. 50 is greater than equal to 80. No. So it will return you F. Okay. So the letter underscore grade contains your F. So whenever you compare the letter grade with the P, it will say, sorry, you failed. But actually you have not failed. It should print you passed, congratulations. But it is printing, sorry, you failed. Right? Such type of problem may happen. That's why whenever you are passing the actual argument to the formal argument, so you have to ensure both are need to be in the correct sequence. If you are writing in the incorrect sequence, compiler is no way is going to evaluate you have written the in a incorrect way. So this is your mistake only, right? That you have to take care while you are writing. So you can see here the input is 98 and 60. Your result should be passed, but it is printing the result is failed due to incorrect sequence. So you have to focus on that. So whenever you go for function definition, so within a function definition, you are specifying the variable. Variable must be declared before they are used, and variables are typically deployed before the executable statement. Okay, and at least one return statement is required. But in the previous case, you have a if else. So in each and every body part, you have a return statement. Like here, you have two return statements in the else part. So like that, if you go for if else statements, right? So if you go for ladder of if else statement, then you have multiple return statement, but you have to ensure that you have at least one return statement. So here you can see function declaration and function definition, whatever we discussed, right? And the function call must be preceded by either function declaration and function definition. Before function call, if you have defined your function, then function declaration is not required. Otherwise, function declaration is required. If you have written function definition prior to the function call, declaration is not required. So placing the function declaration prior to the main function and the function definition after the main function leads naturally to building your own library in the future. Right? Similarly, you can go for bool is a return value. I know that bool value is either true or false. Like here you can see we are writing rate is greater than equal to 10 and rate is less than equal to 20 or rate is equal to 0. Either both conditions are satisfied, okay, then it is true, right? Otherwise, if rate equal to 0, it is also true, right? So based upon the bracket, you are going to evaluate it. So the entire expression will give you either the true or false. So you know that if it is a non-zero value, your output is true. If it is a zero value, your output is false. So that condition also you can put. Okay. So here you can see we have written bool appropriate. Appropriate is nothing but your function name which takes an argument rate. Then you are returning the value either true or false. So it will evaluate this expression. If it is true, then it will return true value. If it is false, it will return a zero value. So that accordingly you can work in a particular function. Okay. This is the conclusion of this programmer defined function. So write a function declaration and function definition for a function that takes 3 arguments. You have to consider 3 arguments. All the arguments of integer type and they will return the sum of 3 arguments. That is nothing but addition of 3 arguments. Next is describing the call by value parameter mechanism. I will tell you more detail in later classes. Write a function declaration and definition for a function that takes 1 argument of integer type, 1 argument of the double type. Okay, so it is taking 2 arguments. One is of integer type, another is double type, and your objective is to find the average of 2 arguments that you have to calculate. Okay. Write a function declaration for factorial with definition and call with parameter. You have to write a factorial of a number program with function declaration, definition, and call using your parameters. You specify the parameter is 5 or 10, something like that. Based upon you have to write the